Hello students, this is the second part of the series of properties of inverse trigonometric functions. Students, in this video I will be proving some properties of inverse trigonometric function. So suppose first property is like it is having three parts. It is cos inverse minus x is pi minus cos inverse x, where x is taken from the domain -1 to 1. Property B is secant inverse minus x is pi minus secant inverse x, where mod x is greater or equal to 1. And C property is cot inverse minus x is pi minus cot inverse of x, and x is taken from real line. So I am proving A part here. How to prove it? Let us consider cos inverse minus x is y, or minus x is cos of y. Ultimately x is minus of cos y, or x is cos of minus y. It can be treated like cos of pi minus y, or it is cos inverse x is pi minus y, that is cos inverse x is pi minus y is treated like cos inverse of minus x. Ultimately cos inverse minus x is pi minus cos inverse of x. So that is our first property, which is proved. Now we'll talk about the second property. What is the second property? So in this second property, my consideration is that secant inverse minus x is equal to y, or minus x is secant of y, or x is minus of secant of y, or x is secant of pi minus y, where it is secant inverse of x is pi minus y, or secant inverse of x is pi minus secant inverse of minus x, as y is taken like secant inverse minus x. That is secant inverse of minus x is pi minus secant inverse of x. So this is the proof of second property. Thereafter, if I will talk about third property, so third property is related to cot inverse. So here I will consider cot inverse of minus x is equal to y, that is minus x is cot of y, or x is minus cot of y, or x is cot of pi minus y. Ultimately cot inverse x is pi minus y, or cot inverse x is pi minus cot inverse of minus x, or cot inverse of minus x is pi minus cot inverse of x. So in this way all three properties are proved. Thereafter I will talk about few more properties of inverse trigonometric function. So in this video, this will be the property number 2. In this property, three parts are provided. First part is sin inverse x plus cos inverse x is pi by 2, where x is from the domain -1 to 1. B part is tan inverse x plus cot inverse x is pi by 2. X is from the real line. C part is cosecant inverse x plus secant inverse x is also pi by 2, but mod of x is greater or equal to 1. So I'm going to talk about first property initially, that is related to sine inverse and cos inverse. So let us consider sine inverse x is y, or it is like x is sine of y. As we know, this sine theta or sine y can be written like cos of pi by 2 minus y, or it is cos inverse x is pi by 2 minus y, or it is cos inverse x is pi by 2 minus sine inverse x as per the consideration, or it is sine inverse x plus cos inverse x is pi by 2. Thereafter, for proof of the second property, my consideration is tan inverse x is y, or x equal to tan of y, where it can be written like x equal to tan of y can be written like this tan y, actually it can be written like cot of pi by 2 minus y, or cot inverse x is pi by 2 minus y, or cot inverse x is pi by 2 minus tan inverse x, or ultimately tan inverse x plus cot inverse x is pi by 2. So this second property is also proved. After that, I am going to prove the C part of this property. For that one, I have to consider secant inverse or cosecant inverse x. Cosecant inverse x of y. Cosecant inverse of x is equal to y, or I can write here x is cosecant of y, or x is cosecant of y can be written like secant of pi by 2 minus y, or that is secant inverse x is pi by 2 minus y, or that is secant inverse x is pi by 2 minus cosecant inverse x as per this consideration, or that is secant inverse x plus cosecant inverse x is equal to pi by 2. That is the proof of this third part. I hope students this video will be helpful for you in your study. Thank you so much for watching this video.